Hi everyone. In this particular video, we are going to cover problem which were actually asked in Google interview. Okay, and these problems we have collected from various resources like Geeks for Geeks and other, where people share their interview experiences and all. So let us directly jump into the problem statement. Okay. So as you can see, you are given a string s of length n. Okay, what I would recommend here is there are going to be multiple videos where we will be covering interview problems which were previously asked at Google. Okay. Now, what your task is whenever you are watching such video, you have to pause the video and the problem when you see the problem for the very first time and try on your own because we are going to explain that. So while we were explaining, you can match, okay, how much you are correct, you are going in right direction or not. Okay. So that is going to help you or benefit you more. Okay. Now let's start. So you are given a string S of length n consisting of digits from 0 to 9. Okay. You need to partition string in k substrings. So we need to partition our string in k substring such that each substring starts with an even digit and ends with an odd digit. Okay. Each substring must to be of length at least equal to m. So each substring need to have at least length m. Determine the total number of ways in which you can partition the string in k substrings and give the answer modulo 10 to the power 9 plus 7. Okay. So let us write down whatever we feel are important and is given in problem statement. What I can notice first is I am given a string which contains nothing but digits. Okay, and digits are represented in form of character. Okay, digits are from 0 to 9. So basically a number is represented as a string. Okay. Next thing that it tells us is we have to partition our string into k substrings. So that is one of the limitation or one of the condition which we need to satisfy. Whenever we are doing partition, there should be k substrings only, not more than that, not less than that. Now what is mentioned here is substrings are going to start. So substrings, whatever substring we want to have, they need to start with a even number, start with even digit. So even digit between 0 to 9 are 0, 2, 4, 6 and 8. These are the even digits. And it should end with odd digit. End with odd digit. Okay, let me remind you, it's a string. So these digits are basically represented as characters or given in the form of characters. Odd digit. And odd digit, 1, 3, 5, 7 and 9. Okay. Now, what's your task? There is one more term that is M. What is M? M is basically telling you what should be the minimum length of substring. So there is one more condition that we need to follow is minimum length of substring should be M. Okay. Or how it is mentioned is at least M characters should be present in your substring. Okay. So we can have any substring whose length is greater than equal to M. So these are the points, important points after reading the problem statement, which we have noted it down. Now, based on these, we will try to come up with some solution. But let me tell you one thing. If you are giving interview for Google, you can assume always, like always, you should have this in mind until and unless your problems is clear, like you completely understand the problem statement, don't move forward and give the answer. Make sure you understand the problem statement clearly. Here, one thing which we didn't mention, find out, like whoever shared the interview experience, they didn't mention about like the constraints. So, and in Google interviews, they on purpose not tell you constraints. They will miss out some of the parts of problem statement because they are expecting from your end to ask those questions, ask for constraints, ask for clarifying questions. So these things you need to keep in mind whenever you are giving interview for companies like Google. Now here, let us move forward. As of now, we are not focusing on the length. Uh, okay, length of the string that can be. Okay, we'll see in the later part. But what first intuition comes to your mind here? Let us randomly assume we have a string. Okay, there can be n digits in the string because whatever is the length of the string, that many digits are present. Now, what I need to do, or what we need to do, is we need to do partitions. Suppose m is 3, so at least 3 characters need to be there in your substring. So we can have partition like this. Okay. Now, can I do one more partition? No, we cannot do one more partition. Okay. Before coming to here also, one thing that you can observe, or before calculating the number of partitions, you can observe this given condition. Okay. Start of any substring. If you are doing partition, then the substring, the starting digit is going to be even. Okay. It cannot be odd. And even the ending digit should be odd. So one thing you can observe is this is your string. This is going to be the very first character of your substring, or the digit of your very first character of your string, or the digit of your string, original string which is given to you. It is going to be start of any of the substring, or more formally the first substring. So there is one condition, it need to be even. The very first digit of your string need to be even. Very first character need to be an even digit. If it is odd, then suppose we have 1, 3, 5, or 7, we cannot form a substring here. We cannot. This very first element is going to be starting of a start of any or the very first substring. Similarly, the last character, it should be odd always. Why? Because it is going to be end point of one of the substring when we do partition. And what is the condition for end of any substring? End character or digit of substring should be odd. Okay. So what if a string is given where the first character is odd or the last character is even? You can directly say that number of valid partition that you can do is 0 because it is not possible. Okay. Now after doing this check, then you will try to do partition in your string. Okay. Now how there can be multiple partitions, I'll tell you. Let us take some example, then you will understand better. 8 to 1, then we have 4, 5, 7, then we have 8, and suppose 6, 1, and we have 5. Suppose these are the digits of our string. Basically, if I'm separating every character by a column, uh, by a comma basically. So this is our string, and let us separate the characters here. What else we can take? Suppose k is 3, we need to do 3 partitions, or let us take k2. So I can show multiple partitions are possible. So suppose k is 2, m is 3. It means I want to divide this particular string into two parts where at least one of the part, sorry, both the parts should have length at least 3. Whatever substrings you are going to form should have length at least 3, means length should be greater than or equal to 3. Now I can have this partition, the very first partition. Okay, at this point, now what is going to happen is I'm going to have, as a result of this, I'm going to have two substrings here. Okay, now 8 to 1 is one of the substring, and the remaining here partition is like I'm dividing them into parts. K equals to 2 means two parts I want to create. Here I am able to create two parts. This is one partition and this is the remaining partition. Is this a valid partition, a valid substring basically? For checking for partition, we need to make sure all the substrings that are being formed are valid. So here, is this a valid substring? Yes, it starts with an even number, ends with an odd number, and length of this substring is at least m, greater than equal to 3. So this is a valid substring. What about this? This is a valid substring? Yes, because it starts with even, ends with odd, and the length of the substring is obviously greater than equal to m. So both the substrings that we are getting from this partition are valid. So our partition is also valid. So this is one of the partition. Can we have any other partition also? So let me write the partition 8 to 1 and 4 5 7 8 6 1 5. This is one partition. This is the second partition. Now coming to the next example, what other partition we can have? We can have a partition like this. Are they valid? Is this partition valid? Let's see. For this substring, it starts with even, ends with odd, and length of this substring is greater than equal to m. So this substring is valid. What about this? It also starts with even, ends with odd, and the length is greater than equal to m. So all the substrings that are being formed in this case are valid. So my partition is again valid. So the next partition that I can note down is this and this. Okay. So for this substring, we were able to find two partition. Let's see we can have any other partition or not. Can I have something like this? Is this a valid partition? The answer here is no. Why it is not valid partition? Let's check. What about this substring? Is this a valid substring? Yes, it starts with even, ends with odd, and length is greater than equal to m. Okay. Now let us check with this. It starts with even? No. Okay, so this substring is not valid. So the partition that we are getting is not valid. Okay. So that's how you can get multiple partitions for a given string. Now, one thing you can understand is you have choices in this particular problem. Okay, what are the choices? You have choices which all elements you need to take and where to do the partition, when to do the partition. This is all in your hand. And whenever you have choices, the best way to solve that problem is using recursion. Why we use recursion is because we want to explore all the choices, and so I'm writing why we use recursion to explore all the choices. And what else? It is easy to write recursive solution. Why it is easy to write recursive solution? Because you focus on any random state. You just focus on random state, and whatever options or choices or decisions you have to make in that situation, you do them correctly. So you only perform right operations for this random state, and recursion takes care of all the remaining ones. Rest states. Okay. That is the beauty of recursion. Okay. So whenever you have choices, try to apply recursion. You can definitely apply recursion at that particular place or in that particular situation. Now, since we are using recursion in this particular problem, I already told you why. When it is string given or array given in and you're performing recursion, either you can move from left to right or you can move from right to left. Okay, these are the options that you are going to have. Okay, now what can be random state? What do I mean by random state? So let us understand that. So random state means you are present in some random situation. What can be the random situation? Here, what is the situation? You have these many digits present at string in these indexes from 0 to n minus 1, where n is the length. Okay. What you have to find? You have to find number of partition. So this is a state. This is a state, or you can say problem. This is your main problem. You have to find number of ways of partitioning all the digits which are present in index from 0 to n minus 1, satisfying all the conditions. Okay, so this problem or sub problem, we call them, or we also call them as state. Okay, nothing else. So you are going to start from your index 0. Okay, you will start from the very first digit that you are going to have. Okay, you already have checked, okay, first digit is odd or not, like even or not. Okay, that check is already done, which I mentioned earlier. First character should be even, last character of string should be odd. Then only you'll proceed to the partition stage. Okay, so now here, if you are picking this particular character, like this is the character, sorry, this is the index from where your new substring starts. Okay, this is the index from your new substring starts. Now a simple question. You need to make sure your substring, whatever substring is there, it is going to have length at least equal to, greater than equal to m. At least equal to m, let us say. Like that is the smallest valid substring length. So what you are going to do is, you took since your substring is starting from here, you are going to take all the characters from this position to 0 plus m minus 1. Okay, or I can say all the characters from index 0 to 2. Let us write their indexes also. 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 2, you need to take all these characters for forming a valid substring, because there is a condition given. The length of substring need to be at least m. Okay. So at least these many characters you require, these many digits you require. Okay. Now what you are going to do is, can you stop or form a partition here? Can you say this is going to be your substring and you are going to divide your array at this place? The answer depends on this last character. It depends on this last character. Okay. Now one thing here you will ask, okay, we didn't check about the character where we are present at. But I already told you, since we are at starting from index 0, and first we'll check like first character is even or not, then only we'll move forward with partition. So there is no need of checking for index 0. So 0 is valid. Now we just need to check index 2. The very last character, very last digit, it should be odd. Here is it odd? Yes. So I can do a partition at this point. I can divide, put a division at this point. I can say 8 to 1 can be one of my substrings. Okay. Now for remaining digits, what I'm going to do is, I will use my recursive function. I'll call my recursive function. Suppose the name of the function is, we have to find all, we have to count basically. So we will count all partitions, something like this. So I will go to that index. Okay, in this case, that index is going to be 2 plus 1, 3, or I can say 0 plus m. Okay, that you guys understood. What you have to do is, when the starting index is at 0, your ending index, ending index of substring is going to be from 0 plus m minus 1 onwards. That you need to understand. It can be here, 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 can be here, it can be here. These are the options for your ending point, or yeah, ending index of your substring. Okay, why? Because you need to make sure at least m characters are present in your substring. Okay, so you will check, since we are talking about choices, and all the remaining indexes, all the indexes from 0 plus m minus 1 to the end, they are they have equal probability or option of becoming last index of your substring. You will try all of them. You will try all of them. So what I am saying here is, let us generalize this. Here I talked about index 0. Let us generalize this. Suppose I am present at index I. I am present at index I. Now, first thing I need to check is, if I'm present at index I, it means my new substring is starting from index I. First thing that I need to check is, okay, obviously you will check the validation and all. Okay. First thing that you need to check is I, if it is going to, if it's obviously the valid index check we already have done. This character at this position or the digit at this particular index should be even. Then only I can start a substring from there. You understood? So it need to be even. If I am done with this check, what I am going to do is, this is my starting index. Now what option I am going to have for ending index? My ending index is going to start from I plus m minus 1 onwards. Why this? Because if my ending index is less than this, the number of characters or substring, length of my substring is going to be less than m. Okay, that is the reason I need to, the smallest index which I up to, which can be my ending index is I plus m minus 1. Okay, so all index beyond that can be my ending index of my current substring. So what I am going to check is, I have to check this ending index. Character should be, or digit should be odd. Okay, character at this position should be odd, then only I can do the partition. Should be odd, then only I can do the partition. So once you are performing the partition, so the next substring is going to start from I plus 1 onwards. Okay. So remaining characters are from, or digits are from I plus 1 to n minus 1. For them, how many partition you can form, or you can form a valid partition or not. For that, you will use your recursive function. Okay. Now, one thing that we missed out here is, you also have details about how many partitions you can do, k partitions you can do, or you need to divide your array into k parts. So whenever you are doing the partition, this k value is going to decrement by 1. You need to understand this thing, and you can only do partition if k is greater than equal to 0. K is equals to 0, it means no more partitions. So if your k value is less than becoming negative, it means you are trying to do a invalid partition or extra partition. K is equals to 0. What does that means? That means you cannot do any further partition. If you try to do that, your k value will become negative, and that is not valid partitioning. Okay. So one thing that you need to understand is, if I summarize everything, keep everything all together, what all comes to the recursive solution part here is, let us say the recursive function always have meaningful names. What I want to do is, I want to count all partition. So that can be my recursive function name. What are the important parameters of this? I'm writing in pseudo part. I'll show the code also. So which index you are currently present in, how many partitions you can do, and m value, what should be the minimum length of your substring, and the string containing the digits. Okay, four parameters are going to be there in your recursive function. Okay, as we discussed, if k is less than 0, if k is less than 0, we can say that this is not a valid partition, we will return 0. Let us, since this is going to return count, we can have int as our data type or return type. Okay, this is there. K is less than 0 means you are trying to do more number of partitions, so that is not a valid partition, we are returning 0. Okay, what else can be there? What if you are able to reach to index n, or when your index is equals to n? So when your index is equals to n, it means you are trying to go to an invalid index. Here you have to check when you can go to the invalid index, when at the last character or last character is basically your ending point of previous substring. From there, the next substring you are going to form is from I plus 1. There, from last index, if you do this I plus 1, your index will become n. So in that case, what you have to check is if k is 0, it means the required number of partitions you have done. So you can say the partition that you have done is valid. So you will count this partition. Return one basically means I found one partition which is valid. You need to understand this particular line, what we just said. If I is equals to s dot size, when you are going to get this, when from the very last character, when you are saying your substring is going to end at very last character, and now you perform the partition there, so what happens? You try to go to I plus 1 after doing the partition. Here just we discussed. Now when you are doing this partition, you are trying to go to next index. Okay. I plus 1th. Oh, it should be j plus 1th. My bad. My bad. It should be j plus 1th index. Okay. Because j is the ending index now. So next substring is going to start from j plus 1. So if j is the very last index, obviously j need to be the last index for last substring. From here you will try to go to next. It will be n. So for that condition, if I is equals to n, here we are checking it's an invalid index. In that case, k need to be 0. If k is 0, it means the partition is valid. Else, if k is not 0, you'll say partition is not valid and you'll return 0. Okay. These are the base conditions. Now we can find what is the current digit. What is the current digit? And the way of finding is like this. What I'm doing here is, say I know that my string is representing the digits. Okay. So I have a string like this 987. Suppose I value is 1. So I want to convert this character 8 into integer 8. So how I do this is s of I minus character 0. So here what happens is they compare the ASCII value and find the difference. I think the character 0 have ASCII value 4 and character 8 have ASCII value 52. So it is nothing but 52 minus 8, it comes out to be 8. Okay, so it basically, oh, sorry, 52 minus 44, it comes out to be 8. So it do this operation between the ASCII values and return you an integer number. Okay, so here we are trying to convert a character into integer. This I need to check. Okay, I is going to be the starting index of any substring, so this need to be even. If it is odd, so I can say that whatever partition you did, we did is not valid. So I'll return 0. I'll return 1 only when I found a valid partition. Else, what we are going to have is we can take a variable who is going to store how many partitions we can do, valid partitions. So here we need to loop for the ending index of our substring. Starting index is I, ending index is going to be from I plus m minus 1 until the very last index. Last index can also be my ending index. And whatever just we discussed, we'll check the same. Here we will check if character at this index is odd or not. It need to be odd. If it is odd digit, then we can do the partition. We'll call our function, which is count all partitions, and we will go to j plus 1th index, and number of partition is going to be decremented, m and s. Okay, if it is a valid partition, whatever value we are going to get from there, we will add to this variable, which is going to count how many valid partitions we can do in this particular case. Okay, and here what we are going to do is we will return this value. So that is going to be a recursive solution. But here the time complexity, if you'll try to find is, it is going to be exponential. Why it is going to be exponential is, let me tell you one thing. When you are at index I, and suppose m value is 1, m can be 1, sorry, m can be 2. So if m value is 2, it means your ending index can be from I plus 1 onwards. So in this case, how many options you are going to have? N minus I minus 1. These many options you are going to have for ending index. Okay, this is for one state. Next state, so I can assume this value to be n in most of the cases. So for every index, you have n options. You'll try them. So it is going to be give you a complexity of time complexity of n to the power of n. Oh wait, we have k also, which we forgot. So n into k to the power n. That is the time complexity that we are going to get. Okay. But one thing we can observe here is we can optimize this solution. How we can optimize this solution is by using memoization here. Okay. When we do this memoization, what happens is my time complexity is going to be n into k. These are the total number of states. And for every state, I have n options. So this is going to be the time complexity. And space complexity is going to be n into k. Why n into k? Because those are like the different states I can have. This is total number of states. And what is this? Total number of different states n into k. And this is for every state how much computation I'm doing. So when we memorize, the time complexity is going to be n into k into n. Okay. So whenever you feel like your time complexity is exponential and number of states are quadratic or you can compute them. So, oh sorry, when number of states are much less than the time complexity you are getting, you can always use memoization. Now, memoization is nothing but it is based on the process, store the result and use it in future when it is required. Okay. So I'll show you the code for this. How we can do this is, so it's a C++ code. We'll attach the code in the video description also. So here the part of memoization is you create an array, starting array here we have created. And since the length was not mentioned, we are fitting the length which we can run with this time complexity of n square into k. Okay, which we can run, or I can also say n cube, n cube time complexity or quadrant, like yeah, cubic time complexity. So 500 fits fine. Okay, even the length is going to be less than 500. Okay, So what we are going to do is, since the size was not mentioned in wherever the problem we found, so we took 501 and 501. This is feasible to create the array. Here what we are doing, we are going to have these parameters: index, k, m, and s. Which index we are currently present at, how many partition we can do more, and what should be the minimum length. N is going to be the size of array. If k is less than 0, it means we have done extra partition, so this is not a valid partitioning. If I is equals to n, if k is 0, it means we got exactly required number of partitions, so we'll return 1, else we'll return 0 because the partition is not valid. Here we are finding the digit, current digit is even or not. It should, if it is odd, it means the partitioning is not right. Now comes the memoization part. Here we are checking if we have the result or not. In case of memoization, we fill our array with some default value. If it is not equal to default value, it means we have the result. We already have updated with the result. Okay. Now here I took a variable val which is going to compute total number of partition in this case. Now j is nothing but the ending index. My starting index is I of my current substring. So j is representing the ending index that we can have. Here I am basically checking if the digit at ending index is odd or not. If it is odd, it is same as this not equals to 0. What I am doing is I am performing a partition there. So the next substring is going to start from j plus 1 and number of partitions are also reduced. Here we are performing the modulo operation because we will get some value, and since we are adding, it can be very large. So we are performing modulo, and before returning, what we are doing is we are storing in our memoization array. So that is the solution for this case. Now here we have written everything. How input we are taking, n and m and k are given. What is the length of string? What should be the minimum length of substring and how many partition we need to do. String s is given which contains the digits. Here we are checking first digit and last digit before performing partition. First digit, if it is odd, it is not possible to do partition. Last digit, if it is even, again it is not possible, so we are directly returning 0. Here we are, as I mentioned, we fill our memoization array with some default value. Here the default value is -1. I'm filling my array with -1. Then I'm calling my recursive function, and this is going to return me the result. So if I run for the following test case, 19234323874229, it is giving me 3. So you can validate this particular test case. Okay. Yeah, so that's it. Time complexity, we already mentioned. Time complexity of this is going to be how many different states we can have. It depends on number of changing parameters. Number of changing parameters in this case are n into k. Okay. And for every state, what is the time complexity, or how many operations we are doing for every state? It is n in worst case, you can say. So this comes out to be n into k into n, or n square into k is the time complexity. How much space we are occupying? We are occupying n into k space. Okay. That's all in this video. If you have